LeetCode number 3867, which is today's daily question, which is sum of GCD of formed pairs. So looks scary at the moment you read the question, as it says like words like GCD, prefix sum, shorting, pair the smallest with the largest. These four different ideas stacked on top of each other in single question. And there is exactly why most explanation either rush towards the prefix part or just throw a code at you to just figure out without telling why this thing is working here, as why pairing is important from the smallest to the largest. So with by the end of this video, you would not just know the solution, you will know exactly how to read a question like this and break it down in very obvious pieces on your own, so that you don't need guidance in interview. You can figure it on your own without any further videos. So if you need the code of this question, the full code is uploaded on GitHub and the link is in the description. Let's break down properly this problem. Before we touch the approach, let's kill every confusing words in this question. This is usually where the beginner silently give up. Okay, not because the logic is hard, but because one word felt unfamiliar and they don't want to admit it. It is GCD, which is greatest common divisor. That is just a biggest number which can divide the two numbers, which I told you earlier. I will provide the link of that video in the description. Let's first study the question. You have given an integer array nums. So you have given an nums array. Construct an array which is prefix GCD, where for each index I, let mxi be the maximum of from index 0 to I. So we have the maximum from 0 to the index I, and in the prefix array we will have the GCD of the current index number and our mx means maximum till ith length. After constructing the prefix grid, sort the prefix grid in non-decreasing order. Non-decreasing means we have to follow the increasing order. There may be equals in between. So form pair by taking the smallest unpaired element and the largest unpaired element. So we need the first element and the last element, and we just have to make the pairs. Repeat this process until no more pair can be formed. So we need to repeat this process and we need to generate the pairs. For each formed pairs, compute the GCD of two elements. So at the pairs we are forming, we need to compute the GCD. If n is odd, means if the length of the prefix grid is odd, we need to remove the and we need to ignore the middle one, because middle one is not forming pair with any other. That's written in line this. So return an integer denoting the sum of GCD values all by all formed pairs. So we are finding the GCDs of each pair. We need to sum all this and we need to return it to the answer. So the GCD of A and B denotes the greatest common divisor. Let us take an example and build the intuition to solve it. These constraints are the silent hint about the question, as the constraint is n, which is 10 to the power 5. So the CPU can perform 10 to the power 8 operations per second. So 10 to the power 5 denotes that if we are iterating and have the time complexity big O of n, that is completely valid for 1 second. And if we have n log n, that will be valid because log n is near about 17. And if we multiply 10 to the power 5 to 17, it will apply. Okay, it will be less than 10 to the power 8. But if we are having a time complexity of big O of n square, so let me make you clear. And if we are having the time complexity of big O of n square, that will generally lead to the instructions this. So we have instructions 10 ki power 10, which is, so 10 ki power 10 is greater than 10 to the power 8, means it is not valid. So our answer should be big O of n or big O of and log n. So that's the hint the constraints is providing us. This is the part every video skips. They just say that we use running max and GCD like you are supposed to magically know that. But let's actually build the intuition step by step. The way you are thinking about it live in a interview. So the very first step is what the question really asks you to compute. Ignore the pair for a second. It's asking to compute the max for each index. Let us compute the max for each index. So let us build the array index. There are two ways to compute the MXI. The way one, way A, let's say. Way A says that at every index I, scan the backward through nums, like from 0 to the I, to find the MXI. So this treats each index independently as if we are let's say we have 2, 6, and 4. To calculate for 2, we need to calculate from 0 to index I. So for 0, we are going to 0 to index 0. So we have the larger as 2. Now for 6, we are going from 2 as 2 is as we have 2. Now another we have 6. So the 6 is larger. So we have the 6. Now again, we should go from 0. So for index 2, we have 0, which is 2, then 6, which is 6, and the 4, which is less than 6, so 6 is the largest. So have you seen that for every index, it forget everything it calculated one step ago, as it do not remember anything. So it goes from here to here for this, and from here to here from this, from here to here to this. So it is the way one. Now let's talk about way two, way B. So way B says that carry a single variable forward as you move index by index. Update it only when you see a bigger element. Okay. So as we were having 2, 6, and 4. Now we have a variable. So currently we are on index 0. So we are applying the 2. Let's say we are having a integer minimum. If we are having integer minimum, so we are at index I equal to 0. We are having 2, which is greater than the minimum. So let's cut the minimum and we will have 2. So fill here the 2. Now at index I equal to 1, we have 6, which is greater than 2. Let's fill this 6. So we will fill 6. At I equal to 2, we are having 6, and now the element is 4. So this element is already greater, so we will not cut. And let's fill 6. So this is 6. So this is including the variable v. So the the way b is better because this is not iterating from 0 to I for maximum times. So we are done with this part. Okay. Now we have this as element. Let us calculate this part. So we now calculate the prefix GCD. To calculate the prefix GCD. Once you have the running max idea, the GCD part is just a direct translation of the question, like GCD of the current I index we have and the running maximum including current number. There is no trick. The question told us what exactly we have to do. So the prefix GCD is like we will calculate the GCD of nums of I, which is 2, and the max of I, which is 2. So the GCD will be 2. We will provide the function as we have discussed in the earlier videos. So we have the nums of I and max of I. The GCD is 2. For 6, then 6, the greatest common divisor is 6. And for 4 and 6, the greatest common divisor is 2. So we have the prefix GCD as 2, 6, 2. So we are having the GCD as 2, 6, and 2. Now, next part is to short it. So as we have discussed in a question, as to short the prefix grid in non-decreasing order. So let us sort it. After sorting, we will have this type of prefix grid available. Now, next step, which is in the question, form the pair by taking the smallest and taking the largest. So we have the smallest at this side and we have the largest at this side. We just need to pick the elements one by one. So a pair is 2 and 6, and second is it is a odd number length array. So we have mentioned a talk here as if n is odd, the middle element is of no use because it is having no pairs. So we have this, and 2 we will just ignore it. So we have 6 and 2. Now 6 and 2 will have greatest common divisor as 2. That's the answer of this question, as we have the output is 2. So even without knowing the official pattern name in advance, reading the question carefully line by line and asking what does this phrase structures look like gets you the exact same place. As to structurally solve the question carefully, we will get at the answer carefully. Now we will have the brute force with the wave 1. So let us calculate the brute force. So we will have the directly code of this brute force, as this question is just a linear execution of the question given data carefully. So at the wave 1, we have to calculate the prefix type of thing. As for 2, we will calculate from 0 to 0, and for then 0 to 1, and then 0 to 3. For each index, we need to iterate from 0. So that will be our brute force. So let us have the question answer at the code palette. So this is the GCD. Now this is the n, which is the length, and we have now built the prefix grid as we have here. We have built the prefix grid. Now this is the brute force. So we are having the wave 1. So in wave 1, we are going from 0 to this, 0 to this, and 0 to this, and having the base as this 2. So for now, for each index, we will calculate the prefix sum. As for 2, we will go from 2 to this, and we will calculate for 6 as from this to this and this to this. So the max we put as index 1, and for each element, we will move from 0 to that index I and calculate the maximum, and then paste it in the prefix GCD of add at the calculating the GCD of the current element and the maximum element we are having, as per discussed in the question. That prefix of I is the GCD of this element and max of I. Then we sorted the array as we are sorting the prefix grid here. So as per mentioned in the question, we need to sort the array in non-decreasing order. Now taking long as an answer, because long is the return type, and we have the number of maximum number at each index is 10 to the power 9. So if even if we add 2 or 3 of it, it will be exceeding the integer value range. So we will have the array at long and left and right, because we need the 2 pointers to just make the pairs, as it is 0. So this is L, and right we need n minus 1. So we are taking L as this, and for right we are having the n minus 1. Now we are having the for loop. When left is less than right, we are not equating it because we are skipping the middle part if it is of odd length. So in answer, we will add the GCD of the prefix of prefix grid of left and prefix grid of right. So we will calculate this, the prefix grid of this and the prefix grid of this, and we will calculate the GCD of it and add it to our answer. So we will add it to our answer. We will increase the left by 1 and the right by 1. We will decrease. So now we will return the answer. To calculate the GCD, we have this method. The method I told you in my previous video. You can refer from that. Let me submit the question. Let us first run it. It is running fine. Let me submit it. Will this question lead to the TLE or not? Let me check it, because it is a brute force. This is leading to the TLE. Now let me tell you the real reason why it is leading to the TLE. I think you better know as this part. So this is the real reason why it gives us TLE, as building the prefix GCD is having big O of n for the outer loop and big O of n for the inner loop. So for inner scan and for outer scan, it totally have the big O of n square, as we can have this on our board. Let me have it on our board as as outer loop is having big O of n, and for each outer loop we have a big O of n which is working inside. So it will create a big O of n square time complexity. And in beginning, I told you that big O of n square time complexity will not work here. I erase it, but in beginning I told you that big O of n square will not work because of 10 to the power 8 thing I told you earlier. Now, how to optimize it? As we will optimize by the way we are using. We just need to implement a variable local to represent the previous max elements in running. So we will go from the time complexity as from big O of n square to just big O of n for calculating the prefix GCD. Prefix GCD. So it will drastically improve the GCD calculation time and further execution time of the question. To implement this, we have that as this is the variable we will implement, and this is the big O of n operation we are using here. So let me have you highlighted. This is the max element we will have. This is the tracking of previous element, and this is the current element. We will find the max and store it in the prefix of I. So this is for same as I explained earlier. So I only change this, and the rest of the code is just similar. Let me run it. So I am taking the test case as to see as it is working or it is providing the TLE. It is working fine. Let me submit it. Okay, so this is submitted. Now I have the thing as we are moved from big O of n to big O of n square to big O of n for prefix GCD. Let us calculate the time complexity of this solution. The time complexity breakdown is as this is the just the max calculation. So it will be big O of 1. Now the GCD performing because it is a Euclidean principle. So it will have the log of the maximum value from this. So it will have log of m. Now sorting will leads to big O of n log n. As you know, the best sorting is big O of n log n. Now this whole method will take big O of n by 2, which is basically just equal to big O of n. Now the GCD we discussed earlier, to perform the GCD here also, this is for each iteration we have log m. For n operation as we are going to n, this is n. Now the log m is very small, so we can just remove it, and this will become the n. It will become big O of n. Okay, this is also big O of n, and we have the GCD in every loop. So it is big O of n by 2 into log of m, as we will have GCD of this also. So log m is very small, near about like 30. So we will have this, and big O of n by 2 will leads to big O of n. Now calculating the max, the total overall complexity, as we have big O of 1 and also we have big O of n, and from another time we have big O of n plus 1, big O of n log n, not n plus 1, n log n. Also we have big O of n log n, big O of n, and this is big O of n. And okay, so this is big O of n. So at max we are having n log n plus n. So which will have the time complexity as n log n, because we can remove that if we are having this. So this is the overall time complexity of this solution, which is far more improved than n square. Okay, we are reached from n square to n log n. That's the full breakdown of the solution from one scary question to just a clean big O of n log n solution. The full working code in Java, Python, C++ is in the GitHub. The link is in the description. If this helps you actually thinking through the problem instead of just copy pasting the code, hit like and subscribe. See you in the next video.